Hello, everyone, and welcome to the third webinar in Inflectra's automation series called Choosing a Test Automation Tool, 8 Features That Matter. A quick reminder at this point for those who have now joined us for the first time in the series, I'd like to tell you a few things about Test Automation Demystified. This is a introductory automation webinar series and has about 7 parts to it. And the general aim here is to help aspiring software testers to get a better sense of what automation is like, what to look out for, what the challenges are, what the opportunities are, and so on and so forth, when to use it and where to use it. You can learn more about the series by clicking on the URL shown in the same handouts that are attached here. And I think, yes. Some of you may also know that Test Automation Demystified is a certificate course. The series participants are all eligible to receive a certificate of completion, but there are some requirements. And if you wish to get a certificate, you will be asked to take a short quiz after each webinar and to attend a few webinars. To make it easier for you to keep track, like I said before, we are going to be sending out webinar follow-up emails containing all materials covered in the webinar, including the links to quizzes, as well as where to find the recordings on our YouTube channel. And with this, I'm handing the microphone over to Denise. And good luck, everyone.
Thank you for the intro there. Can you hear me?
Yes.
Do you see my screen?
Yes, we can see your screen.
Okay, great. So thanks everyone for joining today. I'm Dennis. I work at Inflectra, and at Inflectra I'm working on Europe's test automation platform. So let's start our webinar. So today we're gonna talk about vital features of a UI test automation tool. So, as you might remember, when Robinson Crusoe wrecked on a desert island, his broken ship became a valuable source of provision. And it's easy to imagine that his life on the island could be much more difficult without survived foods, drinks, weapons, clothes, and tools, and he actually had everything for his immediate needs and everything to build a safe future on the island. So remove anything from the list of things he found on the ship, and you will get a potentially dangerous situation. So he could get starvation without food and drinks in short term, and starvation without weapons and tools in the longer term. So, and suffering from natural conditions without ability to build a place for living. So why I'm telling this, we're like Robinson when starting a new test automation project. So with proper tools and skills, without proper tools and skills, we are really doomed to fail. So let's talk about tools that matter. So what features our test automation tool must provide? So I'm going to begin with food and drinks of the test automation world, identification of elements, and user input simulation. So there are different ways of locating a UI element within the application you are testing. So we may assume that an element is always positioned at the same place on the screen. So all we need to remember in this case is mouse coordinates. This method actually works great until the application we test is shown at some different location, or if the screen changes resolution or layout of elements within the application is modified, it is different. So it's like a parking lot displayed on the slide. So today our car is parked at some slot, A5 for example, but next day there can be another car. So if we will go to that slot, we will not find our car. So let's see how it works. So here is rupees. I'm going to start the calculator and record a simple test that will just remember mouse coordinates and clicks. So you can do that with rupees. So I'm starting our recording session. Go to advanced, and here I have so-called analog recording. So once I click Ctrl+4 key combination, rupees starts intercepting my mouse movements. So let's multiply 2 by 3 equals, and then stop recording. So I'm finishing the session, go into rupees, and here I have a statement that performs playback of analog movements. So let's see how it works. I just execute the test, and all my mouse movements will be replayed one by one, so with the same delay as I actually did. So it works okay because my application is still at the same place and nothing has been changed. So let's modify it a bit. So I will change calculator type to scientific. I also have the same buttons here, but if I will play my test, then actually it will click somewhere, it will do somewhere, but it will not be what I really need. So coordinate-based recognition works, can help in some cases, but it's not a panacea, and in some cases it just does not work, especially for modern applications. Okay, so let's move to our slides. Back, the next type of identification of elements is using image recognition. Image recognition works very great these days. So we can remember how an element looks like and then use the image to find the element on screen during test playback. So this method works well until we change application design or there are many similar looking elements. So if we draw an analogy with face recognition, so a system may fail, for example, may not find the right person if we are talking about twins. So let's see how it works. So I have a sample for that as well. So opening a test for image recognition. So, and I will just start it. So what this test has, it has a picture that it will try to find on the map. And then once the picture is found, the test will try to click on the first one and do right click on the second image. So let's see how the playback works. So browser is launched. And now image recognition is working, trying to find restaurants. Okay, so on the first we clicked and on the second we right-clicked. So this is how image recognition can work. But most widely used way of element identification is using some kind of a path of an element within the application. So automation tools recognize hierarchy of elements within application. Most popular and reliable way of locating it is remembering parent-child relationships between elements and remembering some element attributes. So this is similar to a postal address. So when you write a letter, you specify country, city, zip code, street name, building number, some person's name, and this mail just finds its way easily. So if we test a web application, so such path is an XPath expression. So let's look at this simple source of very simple page that contains a single button. So if an automation tool needs to find such a pattern in the element, it remembers its path. So one of possible ways to define such a path is just enumerate the nodes in this tree of elements. So first we go inside HTML tag, then we are inside body, and then we are searching for the button. So this path is what will help an automation tool to find an element within the application on the test. So, and this way is what is most widely used today. So one more way to find an element is using match probability. So when element is found, we typically so sometimes elements just cannot be found. So using methods that I described above. So it means why it may happen. It may happen that because element is not displayed on the screen at all, or because its properties have changed for some reason. So let's look at the simple example. Imagine that a button that we used to find on a web page now has a different name. So it was login button with a space between log and in, and now it is a login button. So it's not actually a problem for manual testing. We were talking previously. So tester executing such a test will easily find the login button with the updated name. So, however, automated tools have some difficulty. To help fixing such a test, automated testing tools try to find an element which is more similar to target element than any other element on screen. And degree of similarity is expressed as some number from 0 to 1. So 0, it's completely different elements, and 1, it's exactly the element that we are looking for. So probabilistic match capabilities are under active research currently, and they already can be found in some tools on the market today. And Rupees will receive this functionality very soon this year. So when we found an element, we typically want to do something with an element. We want to click on it or enter text or hover mouse over the element, and an automation tool must be able to do it. There are two major ways of input simulation. So first, emulating real keyboard and mouse using low-level operating system events. So, and it works great for any kind of application, so be it desktop or web application. So the limitation here when you're simulating physical keyboard and mouse is that you cannot run tests in parallel, and you can do nothing on a computer while such test is running, because you are interfering interactions between automated tool and the application you're testing. So there is a second way that can help mitigate these issues. So second way is to send application level events. So, and it works great with web applications. So when you are sending events to elements, browser level events, then it allows to execute tests on remotely located or even headless browsers, and it does not interfere with what you're doing on the computer, so you can continue to do something while the test is running. So on the slide you can see, for example, on the line 5 where we enter text into username field, we have a doSetText action. And in Rupes, it means that we will send a browser level event to enter the text. And on the line 7, when we are typing password, we are using doSendKeys action. And this action really emulates our physical keyboard input. So both ways are possible with Rupes. So element identification and user input simulation are two must-have features for any test automation tool. And without any of them, UI test automation is not possible at all. Other features are optional, but still very important. So let's move on. So inspection of applications. So inspection or spying, this is the way to analyze internal hierarchy of UI elements inside an application. So here is an example of an UI tree of a Windows desktop application. So here we can look how it works with Rupes. I'm running a calculator, which is desktop application. And in Rupes, I can start desktop spy and track some object within the application. And here in the tree section, I can go to parent. And here we can see that elements within the applications within calculator applications are organized in a tree-like structure. So we have buttons inside panes, and these panes are inside windows. And every element in this tree has some properties. So Rupes can interact with the application at the level of this hierarchy of elements, and using a path-like way find elements within this structure. So when we are talking about web application, this hierarchy looks a bit different. So let's open this very simple application with one login button. And in Rupes, I will close Desktop Spy and switch to some web test. And I will run the web spy. So we will see how the tree of elements, hierarchy of elements looks like inside a web application. So here in the spy, we have the DOM tree of elements. And again, for each element, we can examine its properties and see how it looks like inside the application, how it looks like from the point of view of test automation tool. Okay, returning to our slides. The next big feature is recording. So recording allows to significantly reduce time to build a test. So during recording, an automation tool intercepts keyboard and mouse and captures user actions. And captures all the information that the tool needs to find an element during replay. So let's see how recording works in Rupes. So I'm actually going to create a new test. It will be a web test. I will use Firefox for recording. Okay, new test is created, and I start recording session. Here is my application. So let's pop it up. Okay, resume. So clicking on login. So, and my interactions are now recorded. Logging in. Okay, finish. And after recording, I have all my steps here. All the elements that I interacted with are now in the object tree. They remembered. And for each element, we have all information that we need to find this element during test playback. So this is a path-like identification information. So this is XPath that ProPiece will use to find the element. So the idea of recording is to significantly reduce time to create a test. So if you do it manually, then you need to use SPI, you need to understand the structure of the application, you need to manually build this XPath to find the element during playback. Okay, so when you have a test ready, then you may need to modify the test. And this is where the next big feature vital for test automation tool comes to the stage. So this is a codeless testing. Codeless testing means creating tests without programming. So first step to codeless testing is recording, which we just did. And second is ability to modify recorded steps without writing code in a text editor, without programming in a traditional sense of the word. So, for example, if we want in this test to click on the login button after login procedure was successful, then we already have login status button captured. This is actually this button here in the top right corner. So what we can do, without even touching keyboard, I can choose login here. And if I want to click on this element, I can just select click action. So this is codeless. I did not use keyboard and I did not do programming. So this is the second major feature of codeless is you can modify the test. So let's also do one more modification here. I will just rename the element to have better ID. So since default ID is not very self-explanatory. Okay, so I modified the test. And the third big aspect of codeless testing is ability to parameterize a test and make it data-driven without kind of complex coding. So in ProPiece, you can easily do it by defining a data table. So I just delete the columns that I don't need, rename the columns that I need, and specify data. So I have a couple of lines of data. And in my test, if I want to use data from this table, I simply change type of set text parameters to, okay, let's rename this default value to logins. I will change type to logins and simply select column names. Okay, so I have my test parameterized, and I did not write a line of code to get this. So let's execute our test to see how it works. So playing back. Okay, so data is taken from the table, entered in the application, logout works, so everything looks great. Okay, so The next big feature of a UI test automation tool, after we recorded the test, after we modified the test, we want to execute it. And after execution, we want to have a report. So, and this report consists of several parts. So, since test execution is a crime scene, so if something bad happens, we should have enough evidences to find the culprit. So, and several tools, several assistants can make this investigation easier. So, first of all, in rupees, some of report lines are produced automatically during playback, so you don't need to bother about knowing the status of finding each element and executing each action here. If anything goes wrong here, we should be able to see a problem in the report. So I am going to modify my test a bit. So I want to insert a small delay to be able to interfere with the application and make a login button unavailable when Rupees will be searching for this button. So, and we will see the report. So, executing the test, Rupees enters username, password. Now I click somewhere. Rupees tries to find login button. It's obviously not on the screen. And when it happens, the tool will indicate this in the report. So let's look at the report, and we see here that object is not found. We didn't find a login button, and to have this in the report, we did nothing. So this is what comes for granted. But in some cases, we want to check some assumption about application state. So for example, that when we did a login in the application, we see a logout button. So this is thing that you may need to add to your test. So this is called assertion. So, and when assertion failed, we should see this in the report. So let's insert the assertion here after pressing login button. So I'm going to start recording. Again, there is no login button here, so let's execute just a part of my test to get to the logged in state in the application. And when logout button is here, I will start recording. I will create an assertion. So in Rupees, I simply click Ctrl+1 and see the properties of the element. And I want to verify that inner text of this element is logout. Click in Finish. And inserting this step here. So we added an assertion almost automatically to check that logout button can be seen on screen. So let's now delete this delay and make the password that is used during playback invalid. So I'm using some invalid value. Let's execute the test and see what happens when login is not successful. So we're now opening the report, and we see that we try to verify that inner text is logout, but it is obviously login, so something was wrong, so something did not work. And actually, a picture worth 1,000 words. So you may know already, we may know already that login was not successful and there is no logout button, but why? So what happened before login was not successful? So in this case, we can use the power of screenshots and just take a screenshot after we press login button. So here I use navigator object, which represents the browser, and it has do screenshot action that will create a screenshot of what is displayed on the browser, in the browser at this point. So let's execute our test again to get the screenshot. So enter in username, password. Here is the report. And here is the line with the screenshot. So I can open the screenshot and I can see that login was unsuccessful and for some reason. So this may give me a clue. Either my test is wrong or it is really a bug and I need to log it into bug tracking system. So closing the screenshot and returning to my slides. Okay, the next big feature of UI test automation tool is maintenance features. So maintenance features is what helps keeping tests in a good shape. So helps to fight with flaky tests that sometimes pass, sometimes fail, and helps to adapt to application changes. So when developers change application, usually they want to make existing features better or add new features, and this may lead to changes in UI. And so UI elements may change their attributes and layout. And so, for example, a button may be just renamed to better reflect its purpose or increase probability of user click, or a button may be moved to another location on the page. So this may lead to the situation when information that automation tool captured about the button during recording. So let's call this information locator. So this information may not be enough to find the button in new version of the application. So in this case, locator must be fixed. So, but if, however, this locator is good enough to be still valid after small changes in the application you are testing, so in this case, this locator is called resilient. So let's look at this simple example on the slide. So assume that we have a web page, so with just one button. So if on recording, we will capture position of this button like in the first variant displayed here. We will remember just the name of this button. If developers will change the name of the button, then the first locator displayed here will not be longer valid, so it will be broken. However, if we are binding to ID of the button, login button, then changing name of the button has no effect on the test, and the automation tool will find this element during playback. So we can call this second variant a resilient locator. So, but if locator, okay, just passed. If locator of an element is broken, so then there must be some way to fix it. In Rupis we call it relearn. So, and it can be done either semi-automatically. So an automation tool just asks to click on their new version of the element, or we can do this using a SPI. So let's see how it works. So here is our source of our application. Here is the application itself. So let's first create a test and capture the element. So I start recording and I click on the button. And now my button is in the object tree. So it is here. So if I will flash it, then our piece will find the button. So everything is okay. And let's look at the path of this element. So what we have here is resilient locator. It uses ID. So, okay, so let's break the application. Here I'm going to change the ID. So I will use some other ID, reload my application, and flash it again. And now this element is not found, and we need to fix the locator. So the first way to do that is we right-click the element in the object tree and choose Relearn. Repeat enters recording mode and prompts me to click on the object to relearn. So I click on the element. And let's see what path we have now. So here we have a login button 1. So the tool automatically fixed the locator. We can also do this using a spy. So I can launch a web spy, look at the new tree of elements in the application, find the element that I need. I can create a path manually here and test it. So let's try this one, HTML body button. It's also valid. So I can now test it. Okay, I can find the element and I can learn this element and add it to my object tree. So it is now here. So I can just delete the old element and rename ID of the element I just captured to the login. Okay, so and now my test is fixed. Okay, returning to my slides. So far we talked about locators that require 100% match of an element to the information that we captured to find it during playback. So if we remember element's name and the name changes, then locator is broken. So if we remember just ID of an element and ID changes, locator is again broken. So normally, if after application update the element is still there, it was not removed, and it has just a few attributes changed, but a lot of other attributes, a lot of information, its parents, this information remains unchanged. And this observation may be used to try to find an element that matches most. So we do not require that it will be exactly the same element, but we can be confident with some level. So if we confident with more than, for example, 95% level, then we can consider that we found the element that we need. And here we can go in two ways. So if our confidence is high enough, for example, 99%, then automation tool can just automatically fix locator and proceed with execution of the test. If this confidence is a bit less, then the tool can prompt the user and say, oh, hey, I found an element and I'm 97% confident that this is what you need. And the user can just either confirm that the tool found what is needed and the locator will be fixed, or the user may decline and then fix the test manually. So here is the summary of maintenance tools. So the best approach is to build resilient locators that survive some small modifications in the application. So, and if we have such locators, then the number of cases when we need to fix our tests reduces. So, and Tropies always tries to generate such locators that are resilient to changes in the application. If anything is broken, despite of our efforts to build a good locator, then we have a chance to simply fix the test manually. We can either relearn by clicking on the element or by generating or writing the locator of an element by hand. And the last resort is probabilistic matching. This is an automatic way when the tool can try to guess about the right element and prompt the user to either confirm this guess or decline. Okay, so and the last major feature of a UI test automation tool is test management. So when you make the first automated test for some applications, so it's kind of move from 0 to 1. So you solve problems like how to reliably identify elements, how to better interact with the elements, how to deal with complex controls like trees and tables, and how to validate application state, so and many more of this kind. So when you start creating many tests, and in this case, this is a leap from one to many. So this is where you need test management tools. And your automation tool should either contain test management features or be very well integrated with a standalone test management solution. So some of the major features of test management I can list here is test case management, test case execution, and reporting. So let's see how it works in the case of RPs. So when we are talking about test management with RPs, then this is where Spira test comes to the stage. So in Spira test, a web-based solution from Inflectra, you can organize your test management efforts. So first, we can create test cases and link those test cases to requirements and automated tests. So let's create a new test case. So I'm going to create demo login test. Okay, the test case is created. So, and now in RPs, I can simply save my test into Spira. So clicking on the button. So here is the test case we just created, demo login test. So, and now let's click on the save synchronize. Okay, something a bit wrong, so let me restart RPs. Here is the test case, here is our test, save into Spira. Here is the test case, so now I have save synchronize button available. Okay, creating, saving. All right, so I now have a test case and my automated test is uploaded to Spira. And if we go to the test case, we can see here that it is linked to the demo web3 test I just created. So when we have a test case, we can execute it. To do that, I go to test sets. And here I have an empty test set, or I will create a new one. So new test set. I will name it login test set. In the test set, I need to choose what test cases I want to execute as a part of this test set. Here is the test case I created. And now I need to bother about scheduling when I want to execute the test. So with Spirit test, you can either execute at some planned date and time, or you can execute on some recurrence pattern, so daily or weekly, or you can schedule execution of tests upon a specific event. So for example, when an application build is finished, then we should run our tests. So right now, for the purpose of the demo, I will choose some time here, and I need to specify where to execute my test. Saving. On the machine where RPS is installed, I can close RPS at this point. We have, so let's move it to initial state. We have a RPS launcher application running. So this is a service that queries a Spirit test and asks if there is something that I need to execute. So let's just not wait and force poll. So, and now RPS launcher downloads the test and starts execution. And when execution is finished, then all the results will be uploaded to Spirit test. So we can now move back to our Spirit test, go to the test runs, and here is the test run for the test we just executed. I can go inside and I can see the report with all the lines, and also I can see the screenshot. So now results of execution are in centralized repository, and they can be reviewed anytime by any team member. So this is how test management works. So summary of 8 vital features of a UI test automation tool. So first 2 are food and drinks of test automation. These are identification of elements and user input simulation. Sometimes to work with the application, we first need to understand how it is built, how it looks like from inside out. And this is where we need application inspection tools like SPY. So to save time to create a test, we need recording and codeless testing features. When the test is ready, we are going to execute it, of course, and this is where we need reporting. And application is a live thing, and developers do some changes, it's evolving, and this is where we need maintenance tools to fix and update our tests as well. And if you have more than one test, then this is where we need test management. And when everything is integrated together, it provides many benefits. So it really saves a lot of time. So it's like if we have anything disintegrated, realized in different tools, implemented in different tools, this is like Robinson having food, drinks, weapons, and tools not on one ship, but on 5 different ships scattered along the coastline. So, and integration saves a lot of time. For example, in RPS, you can do recording of tests, modification, execution, and debugging, and you do not need to switch between different tools. So everything is available at a few mouse moves and clicks. Of course, when maintenance is integrated in the application, it also saves time. So actually, test automation is about saving time for testers. So you should do test automation to save your time. And if a tool helps you to build tests faster and more reliable tests, then this is what we really need. An integrated solution is a way to do that. And of course, when we have our tests, we are able to maintain them. We want to run and analyze them. If these capabilities are integrated, it also saves our time. So the features I described today are really just a top of an iceberg. So they are the most important, most vital ones. So they make life possible on the desert island. So, and like Robinson, we can survive having those features. But there are, however, many more features that bring the comfort of city life. So there are many more features like advanced application inspection, organizing tests into a framework, extensibility, support for elements with a complex internal structure like trees and tables, grids, test data management, and other features. But this is another story we will cover in one of our future webinars. So the next webinar. So no matter how good is your test automation tool, there are things that are hard or even impossible to automate. And we'll cover this topic in the next webinar, which is called Friends and Foes of Test Automation. It will be 2 weeks from now. And if there are things that help to do automation, and we can determine that there are things that are impossible to automate, the good news is that we can check all these things in advance before we are starting test automation project. And if we know about that, we can do appropriate planning. And presenter of the next webinar will be Alexey Grunevich, automation expert at Inflectra.
I would like to again thank you, Denis and Alexey, for helping. And just to remind you that our next webinar is scheduled for Tuesday, June 25th at 10 a.m. as usual, and it is going to be talking about so-called friends and foes of test automation. And please do look for an email coming out from me with all the recordings of today's webinar, as well as some additional information like the quiz, as well as a write-up of what Denis was talking about in today's webinar. Thank you for attending, and thank you for your interest in test automation. And I hope you have a great rest of the week, and we hope to see you soon.